Okay, let's get the show on the road. We start by looking at the pod specs. We have 4 pod specs here. The first one is the bank teller and database pods. If you look at the first one here, it shows the name of the pod is bank teller and its role is teller as a label, and it's going to be scheduled on the master node. Then we have the bank database pod with label role equals database, and we schedule that on node 1. Next we have the auditor pod, and this has the label role equals auditor. It's scheduled on the master node, and the host network is marked true for this one. And lastly, we have the bank thief pod. It has the node, it's also going to be scheduled on the master, and it has social engineered way itself into getting the host network equal to true for it. Let's create the pods. As we can see, all the pods are up and running. You can see that the teller and database have the IP addresses 10.0.1.130 and 0.179 respectively. This is Cilium managed pods, Cilium managed IP addresses allocated by the Cilium agents. Now, the other 2 pods, Thief and the bank auditor, have the IP address 192.168.105.10. That's the IP address of the master node here. That's because they both use a host network equals to true flag. Now, let's ping, but before we ping, let's start a TCP down trace, a Wireshark trace on who's talking to the bank DB pod. So I'm going to filter for ICMP traffic that's interacting with this pod 179.0.179 address. Let's just hit that start, make sure it started, and then let's do pings. What we expect here is that all pods talk to all other pods, be able to talk to all other pods, because by default we have Kubernetes allows all pods to be, it's open networking. Now with this command, I am execing into the bank teller pod and looking up the IP address of the bank database pod and pinging that pod, one ping only. So there we go. The ping was successful. ICMP echo request went out and we got back the reply. The source address is 1.30 for the sender, which is the bank teller, and destination address is that of the bank database pod. You look here in the virtual network identifier field, there's a value of 3697. Where does that come from? For that, let's look at the Cilium endpoints. CEP is my alias for that. So when you look at this, it shows bank teller has endpoint ID of 3674 and the identity ID of 3697. That's what we put on that's what Cilium puts on the wire. Now let's ping from the bank auditor pod. Same thing, one ping only, and it's able to ping. When we see this here, it's got an identity of 6. This is the identity of the local host, and the source IP address of 10.0.1.235 that comes from, we look at the IP address of the Cilium host interface. So that is what Cilium uses for all the host network equals to true pod traffic. Next, we ping from the thief. So we do the same thing, we repeat that, and the thief is also able to reach the bank database pod, and you see that they have the same source address as the bank auditor and the same identity. So clearly we don't want the thief talking to the database, bank database. We need some policies here. Let's look at what we can do. So this is a simple Cilium network policy that says allow the incoming traffic from pods with label role equals teller or label role equals auditor, which is our teller and auditor pods respectively, and apply this policy to pods with role equals database as a label. So let's create this. It's created. Let's verify that it is up and running. So Cilium network policy, CNP is my alias for Cilium network policy -OYAML. We see that it's up and running. It's been created and it's what we expect. Now let's run the traffic test again. There we have the pod IPs for reference. Let's clear the board here. And now we ping from the thief. The thief is not able to ping anymore. The request went out, but no response. And let's try the teller. The teller is able to ping with its own ID of 3697. How about the auditor? Guess what? The auditor cannot reach the database pod either because they have the same source address and the same identifier. We cannot tell at the receiver if we are talking to a thief or the auditor. So we need some eBPF magic here for making this happen. There is a convenient script called do eBPF magic that I wrote. What this does is it takes this argument and passing it 34567 as the network identifier, network identity for the auditor pod, and applies that. So first thing it did is look up the container ID of the bank auditor pod container, and associated the it found out the C group ID, which is 9408, and created an association with for that C group ID with the identity we passed in over here when it entered it into the host process net ID BPF map. It also created a Cilium identity object for that so that Cilium can understand that this is there. Now let's try that ping again. This time we're able to ping. The request went out, we got a response, and if you look here in the virtual network identifier field, the value is 34567. This is what we assigned it. Now let's try the auditor again, the thief again. Thief is not able to ping. The thief request went out, but no response. Just to make sure we didn't break the teller, let's ping from the teller too. And the teller is able to ping. That, my friends, is the magic of eBPF for you.